reviewing. A to derivative of exponential, which we learned in set 72, is a to the x log of a. What's the derivative of log base a of x? 1 over natural log of a. Now, one of these will be handy in today's lesson, integrating exponential, right? Today's lesson is, right, instead of taking the derivative of exponential, how do you take the antiderivative of exponential? And if you know the derivative rule, then you're in good shape for integral rule. Say we did this guy. What would, this is kind of like the derivative, a bit like the derivative of 2 to the x, but it's missing what? If that was truly the derivative, what should be there besides 2 to the x? Log of 2, yeah? Are you with me? Okay, if this is truly the derivative, then it should have been 2 to the x times the log of 2 there, and it doesn't have that. If it had that, we would be golden, yeah? Can you put it in? Is this allowed? Can I say, you know what? I really want there to be a log of 2 there so it looks like the derivative. Is that allowed?
No.
Yes and no. Okay. Can I bring a can I just say, hey, now this area under the curve is totally different? Well, no, you can do that as long as you balance. How can you balance that? Okay, now there's actually 2 ways to balance any change to an equation. You can either do the same thing to both sides, if there is a both sides, or you can do and undo on one side. Now this doesn't really have 2 sides. All it has is one side. In other words, it's an expression. So instead, let's go with the old do and undo. What would undo times natural log of 2? What's the opposite of multiplying by log of 2? Divide by log of 2. Now, 1 over log 2, that's a constant, yeah? Hey, you're here. What the heck? Were you here before? Oh, how about that? I can do that as long as I balance with a 1 over log 2. Now, the net change then is this is exactly the same. I put this one out there because it's a constant and I can. But I left this one in here because I want that to complete my derivative. Now, what is this the derivative of? 2 to the x. And that guy, well, it just kind of comes along for the ride. And so, it's actually pretty doggone logical. When you took the derivative of a to the x, it was a to the x times log of a. When you take the antiderivative of a to the x, it's a to the x divided by log of a. You can see 2 to the x over log 2. Are you with me? Now, this thought process, you're not going to actually show this every time. That work is not required every time. That's the thought process, though, on the rule. Do I have a box for putting the rule down? The antiderivative of a to the x is a to the x plus a divided by natural log of a plus c, which is opposed to the derivative, which is a to the x times. It's all like the power rule. Follow? All right, this one, unfortunately, looking at the derivative and trying to figure out, all right, what do I do here? This is not at all the same. These are totally unrelated. And so you really try this, you do this some other way. Because when I took the derivative of log base a, it should be 1 over x log of a. That's nothing like I see here. None of that is there. So it's not really like undoing a derivative kind of approach. Let's try this. I'll get you started. You could change the base to something a little cleaner, like natural log. Do you remember the change of base formula? All right. Doggone it, that means we're going to have to develop it.
No.
Yeah. If you wanted to change that to natural log of x over natural log of a. So you did know it that whole time. It was only after I threatened you that we're going to have to show the work that you're willing to speak. Is that what it is? Huh, okay. All right then. So by change of base, this is equivalent to that. Now the 1 over natural log of a, or the denominator, it's constant. A is a number, so natural log of a is a number. And because it's a number, I can put it out front. The other natural log is variable, and so obviously it's got to stay in there. This is good review. How do you integrate natural log? It's tempting to say it's 1 over x, but that's the derivative, not the antiderivative, right? Okay, this is done by ultraviolet Voodoo. Now, students tend not to think that way because it doesn't feel like two terms, x log of x or x sine of x. But it is two terms because dx is a term and log of x is a term. What is your u? Natural log of x. What's dv? dx. If u is log of x, then du is the derivative of log of x, or the differential rather, 1 over x dx. And if dv is dx, then v is the antiderivative of dx, which is just x, all right? Now with our substitution, the 1 over natural log of a, it's still out there. So make sure it's still out there in parentheses out front. Remember the ultraviolet Voodoo part of this, ultraviolet, UV. So based on what we said there in our table, what's U and what's V? X natural log of x. Put the log at the back so it's not confusing as to what's inside the natural log and what's not. V du integral is x times 1 over x dx. Check? Now the key marker for success in ultraviolet Voodoo is the new integral easy. If it is, then you did it well. If it's not, then you did it poorly. That is definitely easier, so we are in good shape. X natural log of x minus, what's the antiderivative of 1 with respect to x? X plus 2. So then, what we see then is the antiderivative of log base anything besides e is 1 over log of the base times the antiderivative of natural log, which by ultraviolet Voodoo is that. On the homework, you may use these notes. You do not have to show ultraviolet Voodoo. I show it to you in case you get stuck and can't remember it. You can develop it yourself. Show. Okay, understood? So we have those complete, yes? Okay, now let's talk little concepts within a concept. So you've got this how to integrate an exponential and how to integrate a log. You could then throw that in combination with a lot of other integral ideas. For example, this guy. This has an exponential in it, so I could possibly use this, but it's got a little more. So what do you see there? What should I do? I have a product. I would then say, is one the derivative of the other? If one's the derivative of the other, then I might think use so. But is one the derivative of the other? No. So if you get a product where one's not the derivative of the other, what technique do you use? Ultraviolet Voodoo. Okay. Had this been x squared, well then I probably would have used so. But this is not x squared. Then one would be the derivative. So we're going to go with ultraviolet Voodoo. What shall we make our u? X. And our dv? 1/2 to the x dx. I'll say this also. This is from a guy that I was kind of cut a corners kind of student, you know. I had a professor that if you didn't have parentheses around the exponential, he would absolutely nail you because truthfully, it's not the same if you don't have parentheses around it. So He was right in doing it. du is dx and v. Well, that goes to the antiderivative we just learned. What's the antiderivative of 1/2 to the x? A to the x, so that is 1/2 to the x over natural log of 1/2. No, I don't make a plus. Okay, so uv is x times 1/2 to the x over log of 1/2 for the uv. Cool? Minus v 1/2 to the x over log of 1/2 du is dx. The key then is that new integral doable. Is it doable? That's better than, at least it's better than the other one. At least it doesn't have an x. It's got that log of 1/2. That's constant. And so at least we're making progress. So the first part, we'll leave. It's done. But the second part, the 1 over log of 1/2, it can be brought out front. And then you're just anti-differentiating 1/2 to the x. So what do you get? This will go out front. Antiderivative of this, by the rule I just have, is 1/2 to the x. And how many log of 1/2 will I have down there now? 2. It'll be log of 1/2 twice over, and that's squared, by the way, not 2 times, but 2 each one times itself. All right, you tracking? Try the next one on your own, please, or with your math amigos. Math amigo, help me. What concepts to be used? Use of, yes, it is use of. But you pick up 1/2 along the way as a byproduct of that 2x derivative. When you sub with definite integrals, if you change the limits, do you have to sub back? You do not. Okay, the last common mistake is making the mistake that thinking a 0 will yield nothing. In this case, with exponentials, when you put in a 0, you do get something, yeah? What is the inside? It's not 7, it's 6. So your final answer is 3 over log 7. Okay? Because 7 to the first minus 7 to the 0 is 7 minus 1. All right. Let's try this bad boy. How do the volumes come in? Y equals 2 to the x. What's the shape of 2 to the x look like? Okay, it's exponential with a y-intercept of 1, 1, 2, 2, 4, growing exponentially, and it has a horizontal asymptote at y equals 0, but only for the left-hand side of the graph, okay? Right? The x-axis and the y-axis and x equal 3. So I'm talking this region here. This is revolved about the x-axis. Got any more? So if this is revolved about the x-axis, then if you draw a reflection, it would look like that. And if you draw then a slice revolved or 2, it will show the discs that you want to see. The picture could be better, but you get the idea. It's many, 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 many really thin discs, okay? So we talked last week about how it's the sum of many cylinders, pi r squared h's. The pi is typically brought out front. The h is really, really thin. And because it's really, really thin, it's either going to be dx or dy, depending on how it's revolved. In this case, it's like a delta x. You're moving side to side, so it's dx. It'll always be a differential, dx or dy. Now, if it's dx, then the equation needs to be in x terms. The radius is constantly changing. Here's the radius, and here's the radius, and here's the radius. But the radius is how high you go to get to the curve. So the radius is the curve, right? R is the curve. So 2 to the x all squared. This one has a little gimmick. I was going to have you do this on your own, but I don't know if you know the little gimmick you'll need. From where to where? 0 to 3 or 0 to 9? Or 8? Are these x values or y values I should be putting in? They're x values, so it should be 0 to 3. That's a 3. That's still not 2. Okay, now, write yourself a note here. This is hard to integrate. Two to the x to the second. Instead, do a little algebra to make your life easier. What could you do to that to change it a little? Add, or when you do power to a power, do you add exponents or multiply them? Multiply them. Yeah? And that's still not great. Different. Do this, which is adding them but in the opposite order, or doing the exponents in the opposite order. And what's that equal to? 4 to the x. This is much easier if you rewrite this as 4 to the x. 2x squared is the same as 4 to the x. All right. That then is easier to integrate. What's the antiderivative of 4 to the x? 4 to the x over natural log of 4. Derivative is times log of 4. Antiderivative is divided by log of 4. From 0 to 3. Pi over natural log of 4 is all coefficient. I'll leave it out front. What is 4 to the third minus 4 to the 0? 64 or 63? 63. Okay? That makes your integration life a lot easier. If you just play with a little algebra, it's a heck of a lot easier to integrate 4 to the x than 2 to the 2x. All right. Try this one on your own, and we will be done. Is there more?
No.
Did I put any continuous squaring in your homework?
No.
I feel like, you know, the honors kids, I don't know if you know about continuous squares to integrate. It is running long. I'll do the other part of the notes tomorrow. I think we'll work fine.
Then we'll have a test next week.
It'll work out. Do this, please. Go, go, go. Quicker. If there's no base shown, it's assumed to be base 10, which is in math parlance called the common law, not the natural law. Log base 10 is common law. Got this reason. Yes. Okay. Remember from last week, if you revolve around x, it's a up and down slice that becomes a dx slice. Right? This is around the x-axis. It's an x slice, and revolve, it's a dx slice. If it's around the y-axis, then instead of an up and down slice, it's a side-to-side slice, which means the height is not dx, the height is y. Basic idea is if it's around x, use x. If it's around y, use y. I gave you some pointers there, because I too am not unique. You ready? You should use a skill we've already done or we just used earlier in the notes. Ready? Answer? Should be able to do this without a calculator. No? Okay. To start with, do you agree it's sum of cylinders, pi r squared h's? Okay. Are we clear on the fact that the h is super, super thin, so it's a differential? In this case, the differential h is dy. Okay, that's the first, after the shell, this is what I then write. Then I say, all right, well, that means the radius is the equation, but it has to be in y terms. So if y is log base 10 of x plus 1, oh, I didn't shift the left one, did I? No, not bad. It actually should be like this, yeah? That's it. All right, sorry, left one has my picture was bad. At any rate, rearranging this in y terms. How do you rearrange this in y terms? How do you solve for x and put it in terms of what? What's the opposite of log base 10? Oh my goodness, what's the inverse of log? Exponential. 10 to the y equals x plus 1. So what is x? 10 to the y minus 1. Probably wish I wouldn't have done that x plus 1 shift. Oh well, what are you going to do? All right. So the equation then is 10 to the y minus 1. The limits of integration, what are they? 0 to 1 because they're y values. Sweet. Ooh, this is going to be gross. I didn't say calculator, so I guess we're going to use our noggin. I don't know where this is going, but I know this is true. Right? So let's take it slow. What's 10 to the y times 10 to the y? If you say 100 to the y, I'm going to kill you. Okay? 10 to the y times 10 to the y is 10 to the y squared, and I'll deal with that in a second. All right? 10 to the y times negative 1 is negative 10 to the y, minus 10 to the y is minus 2 10 to the y, plus 1. Oui? All right? Let's do all of this piece by piece. How will I integrate 10 to the y quantity squared? What's the gimmick to that? Yeah, 10 to the 2y, which is the same as 10 to the second to the y, which is the same as 100 to the y. All right? This one, we could pull the 2 out front and integrate 10 to the y. And that guy is just integrating 1 dy. No big dealio. Got? Good problems. Got a lot of technique in here. What's the antiderivative of 100 to the y? 100 to the y over, that's today's lesson, for Pete's sake. Over natural log of 100 minus 2. I'm not going to integrate. I'm not going to evaluate all separately. I'm just going to do all antiderivatives and evaluate with 1, 0 to 1. What's the antiderivative of 10 to the y? 10 to the y over natural log of 10. And what's the antiderivative of 1? Y from 0 to 1. Yay, yay? All right, pi times, when I evaluated at 1, I have 100 over log of 100 minus 20 over log of 10 plus 1. When I evaluate it at 0, I get 1 over a log of 100 minus what? What's 2 times 10 to the 0 over log of 10? 2 over log 10 plus 0. All right, combining like terms and calling it good. 100 over log of 100 minus 1 over log of 100 is 99 over log of 100. Negative 20 log of 10 plus 2 log of 10 is negative 18 over log of 10. And 1 minus 0 is 1. At that point, okay. That one was a challenge. This we're going to have to come back to. Completing the square, you thought that was just an Algebra 1 skill? Oh no, it's often used in calculus to make our tangent. So we'll have to come back to that. We're running out of time. Would you get that blue packet out if you haven't already done so? There are two free responses that I want to talk a little bit about in two multiple choices. If you just killed the problem we're talking about, then fine. Work on tonight's homework, especially the free response. Some of you just have this free response down full. Your work is actually cleaner and neater than mine, given that your handwriting is usually better than mine. All right. 15 on the front of the first page is the first one I want to talk about. I have two multiple choices that were missed by more than a third of the people. In this case, roughly about 40% of the people. So I want to talk about this one. What is the issue here? Oh, in this case, the issue was misusing the point of inflection. Okay? If you missed this, would you write yourself a note here? This is a point on the original y-x equation. It's not on the derivative. Okay? Some people use the second derivative incorrectly, right? First of all, use negative 1, 5 as a point. And that implies that 5 equals negative 1 plus a minus b minus 2, or 2 equals a plus b. You see where I'm at? Okay. Using the point as a point means using it in the xy equation. The inflection point is the part that people messed up. Okay. If there's an inflection point here, then that does not mean that y double at negative 1 equals 5. No. 5 is not an outcome on the second derivative. It means that y double at negative 1 changes sign. Probably equals 0. So this is what you should be using in an inflection point. To use that inflection point, you say the second derivative at x equals negative 1 should be 0 if there's an inflection point there. There should be no 5 in the second derivative part of it. It's just on the original curve where you use that. So after that, if you said y prime is 3x squared plus 2ax plus b, and y double is 6x plus 2a. And in using this point, the second derivative is 0 when x is negative 1. That implies that a is 3. If you have the second derivative and you have a 5 over there, you made a very common error. That is not true. If a is 3 and b is negative 1, yay? Actually, did I just waste all my time? What's the answer to this? This should be 8, yeah? Wow, it just occurred to me, I 100% wasted my time. Wow. Did I even need to use that second derivative? Just saw this. Wow. If I put that point in, I get 5 equals negative 1 plus a plus b minus 2, yeah? And that tells me that 8 equals a plus b. Now you're locked into thinking, I need to find a and I need to find b. But do I? No. You want to find a plus b. And what's a plus b? Done. Yes?
It's a minus b, a, and the answer is negative 2, wasn't it?
I don't remember. But what's a minus b? Oh, phew. You're right. Gosh, I thought I overlooked this, so I didn't know. I did it right the first time. So a minus b is 8, and so you do actually have to do it. So the answer is, that would have been a good question, though. Gotcha. So what was the answer? Negative 2? Okay, sorry. Mistake in my calculus. All right, this one, most of you had the first big idea, but there are two big ideas. And the second big idea is coming a little bit more this semester, so it's worth talking about. So This is a complicated problem, but it goes to like this, and this is a great foundation for tomorrow. The density of people varies as you get further and further from the stage. So in just one little region, you get a different density than 1 foot back. So the first big idea is setting up the integral. If f of r is in, if the density is in people per square yard, then just integrating f of r won't give me people, it'll give me people per square yard. To get people, you would then have to multiply that by how many square yards in a region. Then, those would cancel and you get people. Okay, so that's the big idea. You need to take the density function times how much area in a region. Cool? The second part then is the area. The area, it's tempting to say, oh, this is a half circle. It's pi r squared over 2. And the answer is no, it is not. Okay? This is more like, what's the area of that line? It's not the area of this. No. It's not the area of this really wide thing. No. It's the area of that line. And the area of that line is found by straightening it out. And if I did that, this distance would be something like half the circumference. And so pi r. And this thickness, that's where the calculus comes in. This thickness of this is how thick that line is. And how thick that line is just how much do I change the radius by going out a little. That's a microscopic change in radius, which we should call dr. Okay? Therefore, the area is not a half circle's area. It's a unwrapped lines area, and it's pi r dr. And therefore, your answer is C. This idea of something so thin that it can be unwrapped is how you'll find the volume of many things here. It's like if I did a ton of papers within themselves here, you find the volume by unwrapping it. That's what cylindrical shells does. We'll talk about that at 87. All right. Last but not least, the AP free response problems. You want to be getting about a 6 out of 9 here or better. And make yourself some notes here. Okay. First of all, read carefully. This is the rate of change in the number of honeybees.
Good morning, Deputy Jaguars. Please rise to the pledge of allegiance. Ready? Begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Should I just do this start of class tomorrow? This is important.
What do you
I'll do it tomorrow.
We are attempting your original creative writing and visual art for publication. Visit